Hi everyone. In this video, we'll talk about finding limits at infinity for radicals. In very simple terms, radicals are functions that contain square roots. But right before we dive deep into that, we'll go over a very important concept regarding square roots. So the underlying base principle that we all know is that the square root of any given answer must always be equal to a positive number, right? Square roots of something can never be negative. So for example, if I told you to find the square root of 4 square, right? How we would do this is that we know that 4 square or 4 times 4 is 16, and the square root of 16 is just equal to 4, right? If I told you to find the square root of any number x squared, right, we would say this is just equal to x, right? If you look closely, 4 squared over here gave us 4. So in a similar way, we would also say that the x squared gives us x. Is this even true in the first place? Not really, but let's find out. So let's do two examples to check if this is actually true. So first, let's say that our x is equal to 5. So if this statement were true, then I would have the square root of 5 square to be equal to 5, right? We know that 5 square is 25, so the square root of 25 should be equal to 5, and the square root of 25 is indeed 5, and 5 equals 5, right? So yeah, pretty good so far, right? Now in the second example, let's have an x equals to minus 5. So if I plug in minus 5 into this statement over here that so far we believe was true, let's see what happens. So I'd have minus 5 squared, the square root of it, equals to x. In this case, x is equal to minus 5, right? So minus 5 squared is just minus 5 times minus 5, which is positive 25. So positive 25 equals to negative 5. And the square root of 25 is just 5, so it eventually gives me 5 equals to negative 5. So definitely this is not true, because 5 is not equal to negative 5. And the other thing here is that if we assume this to be true, then that would mean that the square root of something gives you a negative answer, because this here is negative 5. And we just said the square root of something can never be negative. Hence, when we do the square root of squares, right, in this case, we had the square root of a square, right? It was x squared. We cannot just say that the square root of x squared is equal to positive x right away. This is only true if x is greater than or equal to 0. Rather than saying this, what is actually true when we have square roots of squares is saying that the square root of x squared is equal to the absolute value of x. We know the absolute value of x is equal to x when x is greater than or equal to 0, or it's equal to minus x when x is less than 0. So now let's see if this statement here is actually true or not using the same two examples. So in the first case, if x is equal to 5, then we know that the square root of x squared should equal to the absolute value of x. So 5 squared is 25. The square root of 25 should equal to the absolute value of 5. We know that square root 25 is just 5, and the absolute value of 5 is 5. So this is actually true. In the second case, we had x equals to minus 5. So now let's plug in minus 5 into this new statement we have. So we say that minus 5 square should equal to the absolute value of x, and x is minus 5 in this case, right? So minus 5 squared is just minus 5 times minus 5, so that gives me positive 25. And the absolute value of negative 5 is just equal to positive 5. So now finally we have the square root of 25, which is 5 equal to 5. So in this case as well, if we use this new statement, this new definition, both the cases sort of work out. Hence, whenever you're taking the square root of a square, so be it x squared, x to the power 4, x to the power 6, 8, 10, 100, 200, 250, and so on. So in that case, the square root of the square is not just equal to a positive value, it's equal to the absolute value, like we just saw in this case over here. The square root of x squared was not just equal to x, rather it's equal to the absolute value of x. Just so that this idea sits well, pretty well, because this will be extensively used over the following 1 or 2 videos, let's do a couple of examples. So first, let's say that we are told to find the square root of x to the power 8. So we know that this would just be the absolute value of x to the power 4, which is equal to x to the power 4 when x to the power 4 is greater than or equal to 0, or minus x to the power 4 when x to the power 4 is less than 0. Right? So this is absolutely correct. But if you think closely in this case, when something has an even power, so like x to the power 4 is just x times x times x times x, right? So let's say that x is a negative number, but if you're multiplying it an even number of times, then eventually you're going to end up having a positive number, right? For example, when you have minus 1 to the power 4, so this is just minus 1 times minus 1 times minus 1 times minus 1. Your overall answer is going to be a positive answer, right? Because you're multiplying it an even number of times. So the key point here to keep in mind is that when this power over here is an even power, you know that the absolute value will always be equal to the positive answer, right? You're always going to look into this side of the definition when the power of the absolute value is an even power. So whenever this power over here is an even power, you can straight away say that in this case the absolute value of x to the power 4 is just equal to positive x to the power 4. Because the power is even, you're always going to have a positive resulting answer. Now let's do a second example. So for example, if you're told to find the square root of x to the power 6, we know that this is the absolute value of x cubed, right? So this is equal to x cubed when x cubed is greater than or equal to 0, or it's equal to minus x cubed when x cubed is less than 0. Now in this case, the power over here is an odd power. So that means that if x is positive and you multiply it an odd number of times, you're going to get a positive answer. Or even if you multiply it an even number of times, you're going to get a positive answer if x is positive. But in the other case, if x is a negative value and you multiply it an odd number of times, then the resulting answer is going to be a negative value. For example, if you have minus 1 to the power 3, this is just minus 1 times minus 1 times minus 1. So the overall answer is going to be a negative answer. So that is why when this power over here is an odd power, you shouldn't directly get rid of the absolute value like how we did over here in this example, right? So keep in mind that when the power is an even power, right, it's safe to say that the absolute value is always going to be positive. But if the power is an odd power, then you really need to decide what the absolute value is going to be equal to. So now this might seem to be a tricky concept, and to be honest, it is kind of tricky. So these are the key points that you need to keep in mind. Whenever you take the square root of a square, so be it x to the power 2, 4, 6, 8, any multiple of 2, then the answer is the absolute value of that answer. If the resulting answer has an even power, then you can straight away get rid of the absolute value because you know that it's always going to be positive. So as you can see over here, the resulting power is 2, which is even. So you can straight away say that the absolute value is just equal to positive. Same thing over here, the resulting power is even. So we can straight away say the absolute value is positive. But however, as we saw, if the resulting power is odd, then you need to keep the absolute value and decide if the absolute value is going to be positive or negative. So yes, keep this in mind, and this is really going to help us solve limit at infinity questions for radicals, which we'll just get into.